Okay, so let's get started. Today we must discuss about sockets, and regarding sockets we have an approach, and I'm pretty sure you heard about it. We have an approach of discussing sockets in the way of UDP, user datagram protocol, and in the way of TCP, transport control protocol. We are going to start with the simplest one, UDP. And before jumping into this, I would like to have an analogy, and I think some of you may know, is a standard analogy regarding the communications between two persons, and is from Andrew Tannenbaum. And I think is anybody who knows about this analogy, the Chinese and Indian philosophers who wants to discuss with each other? If not, I'm going to do my best, and I'm trying to use my electronic artist skills. I am not, I'm just kidding. So let's assume we have the following story. So we have Indian philosopher, this is with black, and this Indian philosopher is going to operate with concepts from philosophy like what is divinity, what is death, what is life, and so on and so forth. So he's operating with various things. And yes, he is an Indian philosopher, and unfortunately, he doesn't know other language. Although, you know, the Indians are very good, most of them at least, in English because they have been a colony. It's not a secret. Okay, this being said, let's call this one IN, India. Okay, give me a few moments. And this philosopher is planning to ask one of his partners, counter peers, another philosopher, which is a Chinese one. And in this paradigm, we are going to simulate client server. So this is Indian, and here I'm going to put as a client is asking something. And I would have the server, and this one I'm going to put with blue, and the server is looking like this. Is anybody who cannot see my drawing? I think everybody is seeing, right? Okay, good. So I'm drawing two persons in here. This second person again is the Chinese, and this Chinese is the server. So I'm going to do very fast like this. 1, 2, and finally 3. Let's modify a little bit this analogy, and I'm going to do other analogies. So this is Chinese, CN, because if I'm going to put CH is, you know, Switzerland. So this is server, and is the Chinese one. And let's assume they want to discuss one to each other about what is life. Okay, this being said, let's assume they do not have a common language like English. They do not understand English. And therefore, they must do what? So when the client, the Indian, is going to ask what is life, is going to write this text on a papers, and in the papers after is written in Indian language, then is going to use a translation service. Doesn't matter he has access to a secretary, to an office of translation, official or not, or to Google Translate. This with Google Translate, I'm assuming you are aware, it cannot be used in China. So this being said, I need, when I'm doing this request, what is life, and I'm putting an arrow like this with black, is the request. What is life? This request is coming in Indian language, and this is simple call request. And as I have told you, could be a question like, what is life? Okay, this being said, I have this request, and this request must go, as you know very well, to a translation service, as I have stated a few seconds ago. So it's going to a translation service, doesn't matter this is performed manually by some translator or secretary, or is performed, let's say, automatically with Google Translate. So actually does not matter. So what I'm going to highlight in here is the following. So I have the text and I'm translating from, as I have told you, from Indian language to, let's say, a common language like English, but could be French, German, whatever common language I have access between two parties. These two parties, the Indian philosopher and the Chinese philosopher. And as you can see in here, let me draw like this, right? So I have this service of translation. So in this case, my request is going to perform the translation by a secretary from left side to right side. So I have the translation from Indian language or maybe old Sanskrit to English. Then if I'm keeping this analogy, so I have this translation, put it on another piece of paper, and this paper is then enveloped in some envelope and is sent it by using the standard postal services. If I'm keeping the analogy with Google Translate instead of secretary, then simply after Google Translate, I simply click send, and the envelope, the message, is sent to the peer party, in my case, server, Chinese server, which is going to be asked. Let's assume the more standard way. So I have the postal service. So my secretary, I mean the Indian's philosopher secretary, is sending the physical envelope to standard postal office. And from there, I have a car which is transporting the envelope from India to China. Okay, good. So let me have this. I'm doing my best to draw a car. So I have, this is the car. Okay. Please do not laugh. Okay, so somehow this is the car. I'm going to do the, okay, wheels. So this is the car, and sorry about this. And of course, I'm doing my best to have the car sending this request from India to China. So what you can see in here, let me go like this. My car is traveling between two countries, and in here I would have, of course, the another postal office, and very fast I'm doing my best to have yet another car. And this car, of course, could be a little bit different because my envelope switched several cars. And yes, come on. So I'm drawing my car in here like this. Sorry about this. And let's have the wheels, and that's it. Now, what is happening with my request? So my request, as you may have noticed already, is going to get somehow up from bottom to up. So till now we got top to bottom. Right now we are going bottom to up to go from English to Chinese. So I'm going to put right now English Chinese text. So actually Chinese and then English. So I have something like this. Okay. And then it's translating right from English to Chinese. That's it. So I'm doing some steps exactly like I had in here from Indian to English. Right now, of course, I have to from English to Chinese. So let me show you. And I have something like this. And then finally, my request in Chinese got to my Chinese server, actually my Chinese philosopher. This is receiving the request, and after processing 1 day, 2 days, 2 hours, few minutes, doesn't matter, is going to reply with the response. And the response I'm going to put with blue and is answering. So I have some response in Chinese, right? So is answering my philosopher and is saying what is life. I would be curious. But nevertheless, here, besides my curiosity, this is the response with blue. Sorry. Give me a few moments to put with blue. And yes, I have text with blue. And here I have response. Good. So I have my response in Chinese, then it's translated, doesn't matter, manually translation done by the secretary of the Chinese philosopher or by Google Translate. But again, Google services are not working in China. Of course, they have some substitutes, they have some other alternatives, but nevertheless, they do not have Google. So because of politics, that's it. So I'm going from Chinese into English, as you may observe. And then therefore, what I'm going to have in here, of course, I would have something like, yes, I have in English translated, then vice versa on the same way, but of course, going with the envelope from translated from Chinese to English, I'm going to the postal office, and the postal office, of course, is doing the way back. So is going back from China to India with the reply, with the response. Of course, from here, the envelope is arriving to the secretary of the Indian philosopher in English, then is translated in Indian language. And then finally, our Indian philosopher is getting the answer from his colleague, Chinese one, what is life? So as you can see in here, we have what? And I'm going to draw with green. We have a stack of protocols. So what is a protocol? Is a suite of rules, right? And for instance, we have at least here 3 layers, 3 levels of protocols. That's why I have a stack of protocols. Look, this is the first, and I'm doing my best to draw right now. This is the first layer of the protocol. So this one from here is the philosophical layer, right? So the application layer. Why? Because, you know, doesn't matter the language, the Indian and the Chinese philosopher are operating with same topics, right? What is life? What is death? What is God? What is the man? And so on and so forth. So are operating with the same terminology, with the same knowledge in a way or another, and they are operating with some certain rules. So therefore, they have here protocol P1, so protocol of the philosophers, P1. This is fine. Then we have the second layer, protocol P2, layer 2, right? So actually in networking, this from here, in networking, this from here, yes, P1, protocol 1, protocol 2, and protocol 3. And actually, as I have told you, in networking, this is called layer 0, actually physical layer. Let me put it green. Layer 0, and you met this in the network, and it's called physical, not philosophical, it's physical layer. Then you in our case as analogy, this is also specific to transportation layer. Transportation, as you can see, I'm transporting the envelope, transportation layer, right? Then we have, yes, on the top and foremost is layer 4, let's say, is the application layer, okay, APP. And somewhere we can discuss about ISO model regarding session and so on. But let's stick to our analogy. So we have different layers. We have the protocol layer of the philosopher. Now let's see the protocol level 2, where we are operating with certain rule of translations. And you know very well that I have a lot of rules in grammar, in vocabulary, in translation of the words. I cannot translate mot a mot, word by word, what I have in there. I'm operating with different constructions of grammar, different topics, and so on. Think about the word socket, the one that we are going to discuss today in depth regarding UDP programming, networking programming in Java, therefore socket. So we even cannot translate this in Romanian language. We can translate like priză, soclu, but it's awkward. So we are operating with different type of rules at this protocol level. So you see, this is yet another protocol. And finally, we have the transportation protocol, right? These are different rules, are different beasts in here that we have to handle. So for instance, in the envelope area, I have to handle what is the address of the destination, what is the address of the source, eventually routing, and eventually transportation with a car or by airplane or by ship, right? Navy ship. So therefore, I have yet another rules. And what you can see in here is a stack of protocols on both sides, right? Sides of the Chinese and the sides of the Indian, in order to do a communication. Exactly like you see in here, and this is inspired from an example from Andrew Tannenbaum book of the networking, exactly like you have in here is happening also in the computer. So in the computer, what we have, let me show. In the computer, we have the following, right? So in the computer, as you can see in here, we have, and today we are going to discuss, let me do my best to have something like this. I'm going to explain immediately. So no, I'm going to do like this and simply, okay. So what we have, look at this picture in the left side, right? So in the left side, as you can see, I have TCP/IP protocol stack on each node computer, actually, on each node in my network, right? This is networking programming. And networking programming in terms of, you know, multi-paradigm programming, what we are discussing in this discipline, is an architectural design pattern. So is another paradigm, the client server, when the client is requesting something and the server is replying the response. Okay, so each node, both client and server, have the same TCP/IP stack. In our case, the same stack with the philosopher, translation service, transportation service. As you can see in here, I have application service layer. This is the layer for the philosophers in our analogy. And then the translation, I would not assimilate with a layer in here, would be something in between, which is not. And then the postal office is assimilated with transport layer, with internet layer, and link layer. And as you can see in here, in this transport layer, I have two protocols. TCP, we are going to discuss next week, and user datagram protocol, UDP, we are going to discuss today. The difference between these two are yet as another analogy. So TCP is like you are calling your friend via a phone, over the phone, right? So you are calling and is ringing, and then if your your friend is going to answer, then you establish the connection. Actually, what we call in TCP, we have a TCP handshake. And after this handshake, you start communicating. So you establish a connection. That's why TCP is called a protocol of communication, which is connection oriented, right? You have to establish, you must establish a connection in order to discuss with your friend. Whereas UDP is a little bit different. UDP is like SMS services or WhatsApp messages services, or like, you know, even our standard old-fashioned envelopes, right? So you are sending an envelope to your friend. If he's not home, he's going to have it in his postal office, right? And in his block, is going to remain in there, what, I don't know, for 1 month, for 2 days, whatever. And when he is getting home, he is getting the envelope, is opening, and is reading your content. So more or less, this UDP is assimilated as analogy, and this we are going to do today, like SMS. You are sending an SMS, and your friend is going to receive it, and when he's having time or is opening the phone, then it's going to see the message. So these two, both of them are relying on communication over IP, Internet Protocol. So Transport Communication Protocol versus User Datagram Protocol, both of them are relying over IP. And this IP is packet oriented, you know, and as long as it's packet oriented, you imagine it's not so easy to simulate connection with envelopes, right? It's like you are sending a lot of envelopes very fast, a lot of SMS is very fast, a lot of messages in WhatsApp very fast, and then you see a continuous communications between the client and the server. Okay, along with this and this analogy, and I'm going to save this image again, along with this, we have the concept of encapsulation, as you can see in here. So in our request, our data, what is live, has been encapsulated into UDP header, then in the left part, IP header, then in the left part, we have frame header, which is specific to physical address. Long story short, here at the UDP, I have the port of the application. So each application can occupy, can bind to a port in order to send a message. In our cases analogy, what you see here with violet, purple, and this teal green, in a way or another, not this green, right? What you see, these headers are assimilated in our analogy with the entire transportation system, meaning like this, if you want. In programming and in computer science, frame header is having the MAC, source and destination, you know, the address of your network board. Doesn't matter your board is Ethernet over the cable or Wi-Fi over the wireless, right? So you have MAC address or MAC address. Then in IP header, you have usually IP version 4 or version 6, but most likely version 4. You have again IP of source and of the destination. Think about the envelope. You have to put in the envelope the full address of the source and the full address of the destination. And in UDP, you have the port associated bind to the application. So as analogy, we have what? In the frame header, I would have, for instance, the country and the city where I have to go. In the IP header, my envelope should have what? The street, the sector, the number of the street, and if it's not a house, it's a block, eventually the number of the block, and that's it. I mean, you know, block number, whatever, 30 or 82 or whatever. And the UDP header, if you want to assimilate with this analogy of the Indian philosopher Tannenbaum and Chinese philosopher, right? So then you have the apartment number. So inside of a block, you have, let's say, 100 apartments. Each apartment you can assimilate with an application. So each apartment is an application. One is Adobe, the other one is a browser, the other one is whatever you are using for surfing or for editing images like Paint and so on and so forth. So each apartment is an application. And as long as you bind your apartment to postal number inside the block, number 50, let's say, this is port number 50, actually is your application, is the envelope dedicated to your application, dedicated to your apartment, actually to the apartment of the Chinese. The Chinese is going to receive that envelope, is going to have translated by his or her secretary, and then is going to reply on the vice versa route, right? So this was the encapsulation thing. I'm writing on the paper and I'm encapsulating in some envelope where I put the full address of the source, full address of the destination. And long story short, the TCP and UDP header have the source and the destination port. IP header is having, of course, Internet Protocol source and destination. And finally, frame header is having MAC address or MAC address of the my physical network board. Doesn't matter is Wi-Fi or is is Wi-Fi or is Ethernet. Long story short, let me show you on a terminal. Even I'm on macOS, doesn't matter. It's the same in Linux or in Windows, right? So I'm going to have something like this, and let me show you what I have right now here, right? So I don't want a new one. I want in this terminal a new tab, for instance, and then I'm going to close it. Please take a closer look. So I'm in this terminal, and if you are on Windows, you are going to type ipconfig in your command prompt, right? Because I'm in macOS, is the same like in Linux, is a flavor of Linux. I have ifconfig, right? Config. And as you can see, what you have in here. So long story short, I have my IP address. Let me show you. This is my IP in this moment, given by Wi-Fi router 192.168.0.104, right? This is the IP address of version 4, meaning I have for the address 4 bytes, 32 bits, right? Then I have my MAC address, and my MAC address, as you can see in here, are bytes, and in my case are 6 bytes. Is just you know, a coincidence that my MAC address is like an IP of version 6, so an address internet protocol of 6 bytes is just the MAC address, right? So as you can see in here, what I highlighted is about the frame header, most important. MAC or MAC, source and destination address. In my case, is my macOS. If I'm playing like a client, is going to be source in the request. If I'm playing like a client, in the reply is going to be destination, because think about the envelope. When somebody is replying back to me, the source and destination address are exchanged, right? So I'm going with the envelope from India to China, and then when I'm getting the reply, the China is becoming the source and the India is becoming the destination, so vice versa, right? So this is the MAC address, this is the IP version 4 address, this is IP version 6 address, and as you can see in here, in IP version 6, I have 6 bytes associated with my address, right? And long story short, I have everything in here, but I do not have the ports because I did not actually run any process in this moment to do the binding to the ports. So we discussed about encapsulation, and you see it in here. And of course, during the communication, I have from the client this encapsulation going through the network, and then we have the reverse process of encapsulation going to the server, and the server is getting the text or whatever message, binary message, and is going to reply vice versa with again encapsulation going through the network, and then reverse process of encapsulation and getting the reply. Good. Let's discuss about yet another concept, is about multiplexation, right? Multiplexing, actually. Multiplexing, meaning at the port level, doesn't matter is UDP or TCP, is what I have stated a few minutes ago as analogy. So when an envelope is arriving in some certain country, city, street number, street name, whatever block, and is getting into the box 50, let's say, associated with apartment number 50. This meaning what? I have a process which in terms of multiplexing is associated with this port 50 and is going to receive that envelope, right? So it's going to receive that envelope and is going to read what is in there. Of course, in the real world, most of the applications are heavily using port 80, right? Think about YouTube, think about your WhatsApp web, think about everything. They are trying to use port 80. But nevertheless, for instance, VNC and remote desktop, they are using different ports. So VNC for remote desktop on macOS or Linux machines, you are using, for instance, TCP and or UDP port 5900, 5900, right? So, but most of the applications in our modern world are occupying port 80. And before jumping into the debug session for UDP, what you should keep in mind, look in here. May I delete this? So I have saved the image several times. So I'm clearing all my drawing. So as I have told you, I have my text or my message, binary message. And then what was the first header put up front to my message from the Indian philosopher, from the application level of the client? UDP header. You see, UDP header is having 2 bytes, 16 bits of source port and destination port. So source apartment, destination apartment, and some checksum and length. Then on top of this, I mean in front of this UDP header, I have IP header. Hold on. You say, okay, but TCP header, look, is having the same source port and destination port. Yes, indeed, is normal. I'm on the same level of the communication protocol. I have TCP and UDP. Even today, we are focusing on UDP. So yes, both of them are having the source and destination port. So the source and destination apartment in our analogy, and both of them are putting in the first place immediately after the message. You see, up front the message, not sorry, after the up front the message, right? UDP or TCP header. Okay, now you may ask, why is so complex the TCP header? This we are going to discuss after 7 days, because besides source port number and destination port number, I have sequence number, acknowledgement number, and so on and so forth, right? I have some TCP checksum. Of course, I had checksum here in UDP header as well. Now, what is coming up front of this UDP header, right? So I have the apartment source, apartment destination. Actually, the port, source port, destination, the number which actually identifies a process which is bind to that port. Okay, then I have the IP header. IP header is looking like this, right? So IP header, I have in it what? The source IP address on 32 bits if it's IP version 4. But if it's IP version 6, I would have what? 6 bytes. That's why it's called 6. 6 bytes for identifying the address in the internet of the source and address in the internet of the destination. But let's stick to this simple one. It's much more simple to understand. Source IP address on 32 bits, destination IP address on 32 bits, right? So I have these two. Okay, this is fine. Then, as you can see in here, I would have what? I would have also the MAC address of the frame header. This I did not put in the picture because I want to show you with the Wireshark on a real, totally real sample. Okay, this being said, let's move forward. And in our case, I'm going to do something like this. So I'm not jumping into discussion of TCP at this moment. I'm just jumping regarding this UDP client and server. So I would have a socket primitive on the both sides. So what is a socket? It's an operating system primitive implemented in C, cooperating with TCP IP stack provided by the network interface board, physical, electronically, board which is managed by the driver inside of the operating system. So these components are cooperating each other in order to provide for me networking, communication. And as long as I have networking and this communication, me as a software developer, as a programmer, I can use the abstract concept of the socket. So what is a socket? Is a way of calling a native operating system primitive in order to create in programming language a communication point within the network. So it's a node in my network, a node where I can communicate from and into using the communication Wi-Fi or Ethernet or whatever other barrel transport layer I have. So long story short, in a PC, I can have multiple and several sockets. One socket is for connecting to Facebook, another socket for connecting to Dropbox, or to Google Drive, and so on and so forth. So I can program this, and more than this, the socket can be TCP or UDP, right? So today we are focusing on UDP, user datagram protocol, where I'm concentrating regarding the communication between two parties by using, you know, envelopes, by using SMS, by using messages as analogy, right? Text messages. Okay. This being said, I have what in the server side, almost mandatory, I must have the bind, right? Because my application has to bind to some certain UDP port, right? On the client side, I may have it or not. If I not have it, then the operating system is going to provide to me a number, a random number, which this random number represents the port of my application. But nevertheless, I can have bind on both sides, right? So I can have bind in the UDP server, I can have bind in the UDP client, and then I know for sure, for instance, this is apartment 50 and this is apartment 90, and they are communicating each other. Doesn't matter, are in different cities or in the same city or in different countries or same country. Now, the request on the client behalf is done by calling the operating system primitive send to, and I have the request, what is live. Then in the mirror on the server side, I must have received from operating system primitive and is receiving from. Usually this in Java is blocking, but I can do it with a wait async like in C#, or I can do it asynchronously in a way or another, but it's not mandatory. By default, by design, in the Java net package, I have Datagram socket together with Datagram packet, but actually Datagram socket class from JavaNet package is going to provide receive method, non-static method, as well like send to, which these two methods in Java are by design blocking methods. So I'm not going forward unless I'm receiving a packet from the network. And then I'm processing something. I have to reply what is life, is something beautiful, blah, blah, blah. And then I have to send to the response. And you see here again, I have in the mirror send to receive from, and then close. Please pay attention. Doesn't say anybody that I cannot send the request several times, or doesn't say anybody that I cannot send request 1, 2, 3. Then I have received from 1, 2, 3 in here in the row. And then after these 3 requests, I'm bundling the response in only one, where I'm putting the response in 3 times in a row. So it's up to me how I'm establishing the set of rules, the protocol at the applications level, right? So it's not mandatory to have only one request, one response, one request, one response. This is happening in HTTP, one request, one response, one request, one response. In HTTP 1.0 and 1.1. In 2.0, because it's binary, I can have multiplexing, so bundling of the requests, multiple requests in only one, and then bundling of replying in only one. Anyway, so this request response, this client server paradigm is yet another paradigm. Of course, is not the source code level, like the functional programming versus object-oriented programming like we have discussed till now. It is at the level of the architecture in the network. So is an architectural design pattern, is a multi-paradigm approach of the client server. Of course, I can have multiple paradigms in here as well, like peer-to-peer, right? P2P. Okay, anyway, this being said, let's move forward to more less abstract things and to real debugging things. So for this, I'm going to start a virtual machine on Linux. So I'm on macOS, as you can see in here. I can start a Linux or a Windows, doesn't matter. Let me start the Linux very fast. And what I'm going to do in here is VirtualBox. I'm going to play with my Linux, saying, yes, it's a Linux Ubuntu 16. And in my Linux, I'm planning to have the networking, as you can see in here, as a bridge adapter, not network address translation, over Wi-Fi, right? So I'm using like this, and I'm going to start this. And let's see, I have 2 different machines, like now, with 2 different IPs. I have my macOS host operating system, but let's assume it's like a different, I mean, it's a different operating system, but a different physical machine with some IP, and I'm going to write it down. And then I have my Linux in here, Ubuntu 16, which again is with some different IP, is yet another node in the network. So I have 2 nodes in my network, as you can see. Okay, as you know very well, this is password stud from student. Anyway, so this I'm planning to use like whatever client. I can do it also like a server, but I'm planning to use like a client. And then on the macOS, I'm planning to use like a server, right? So, or vice versa, doesn't matter. What you can see in here, I have in this project, S10 JPP UDP socket, I have 2 files in this package, eu.asa.net UDP, right? I have the client and I have the server, right? So let me show you. Meanwhile, this is started. So yes, I'm preparing to run very fast, the client and the server. So in /home/stud/java se, for instance, I have in the lecture sides, you know, the lectures are always in command line. I have lecture number 10. We are 1 week behind, so we are in 11th week, but de facto semantically we are in the 10th because of the Easter and the 1st May. And I'm going to focus on this very simple sample, UDP simple 01. And for this, for instance, I'm planning to run only the client Datagram socket. And the client is looking like this. Let me show you. So I'm doing in here what? So you see, first of all, I need to import JavaNet packet. Second of all, I wanted to keep it this very simple, that I have public static void main method, and I'm operating with two main classes from JavaNet. First is Datagram socket. So again, what is a socket? Is an abstract concept translated into less abstract object from this class Datagram socket, which represents a point of communication in the network. Of course, in a physical node like a desktop, smartphone, laptop, whatever in the network, I can have multiple sockets, and even in a process, in the same process, like I'm here in the same program, I can have multiple sockets. But therefore, if I have 100 programs and 80 out of them are cooperating over the network, in each program I can have, for instance, 2 sockets or 5, whatever, 2. Therefore, my machine is running 160 sockets. So I can have multiple sockets. And right now, look, yet I have a client socket. I can provide any name of this object as well. So as you can see here, what I'm doing, I'm going to pass as a parameter from the Linux the IP address of the Mac, and I'm receiving this in the command line. And as well, I'm sending the port address, right? I mean the port number, which is in our analogy the apartment number. I'm creating this object address from init address, and port is actually an integer. And then I'm creating yet another object from the second most important class, Datagram packet. Think about your letter inside the envelope. I mean the Indian letter in philosopher to the Chinese philosopher in some envelope. I'm creating a packet. And what I'm putting inside this envelope, in this packet, I'm putting the buffer and the buffer length I have to provide. What is the buffer and buffer length? It is actually the payload, the message. In my case, is hello. In the Indian philosopher was the question, what is life, right? So I'm putting this inside my package. And then on the envelope, I have to state it, look, this is a question or is a message in the end of the day, addressed. So has to go to arrive in China to the Chinese philosopher. So I'm putting China, Beijing or Pekin city, and in there I'm putting some street name and some number and some eventually block. And once the letter is getting in there, then I have the apartment number. Let's assume it's 778, and this apartment is going to receive my letter, which is containing the question, what is life? So, or in our case, very pragmatical one, is just a hello message. And then I'm sending this into the network. How? By using client socket from line statement 11, where I have declared, as you can see in here, I'm using this by calling non-static method send, and I'm sending my packet, which I have declared in line 21. And I'm sending this message in the network, and then I'm expecting the answer. So the answer is coming. I can use the same object packet, or I can create another object packet receive, but from the same class, of course, data structure, Datagram packet. And I'm going to receive the message, and what I'm going to do it to display on the screen. So I have the client in here, and then I have the server on the macOS side. In my programming, let's say skills, I strongly advise to you, besides the debug session in each IDE, doesn't matter is Eclipse, IntelliJ IDEA, whatever, I strongly recommend in networking programming to use a traffic analysis tool. The best ones are TCP dumping command line if you are on the servers on Amazon or on IBM or on Google or on Oracle clouds. You don't have the user interface, and therefore you cannot install Wireshark, and therefore you are operating over command line always. So for the command line, TCP dump is a very good tool. In our world, a very good tool, and I strongly recommend to you to debug your sessions like this, is Wireshark, right? Shark is rekin and wire is fir. Rekin pentru fire de comunicație. So I have Wireshark. This is a tool that is mandatory in your debug session. Otherwise, you are going to learn by heart. Okay, so that I have shown you is my Linux client. So my Linux is going to play the role of the client. And in my communication process, the Wireshark I can either put into the Linux machine or into client machine or into server machine, into my macOS. It's up to me where I decide, right? Let's focus a little bit what I have on the UDP server side, on the macOS side. So on the UDP socket, as you can see in here, I'm using try with resources. So instead of having something like this, socket datagram socket, and then closing on the finally statement, more or less is the same, because datagram socket is a class which is implementing auto-closable interface, meaning that after my special try, which is not starting with this bracket, is starting with this round parenthesis and then bracket, meaning look, when my try statement is going to end, then automatically close is called. So according to my PowerPoint presentation, I'm going to show you according with this, right? So I open the socket on the client side, you see in the Linux machine, I'm sending message, and then I'm expecting for the answer, and then I'm closing, right? This was on the Ubuntu Linux client, right? So I'm opening the socket, I'm sending some packet in the network, as you can see in here, and then I'm receiving the packet. And then finally I'm closing this on the client side. On the server side, on the macOS, I'm doing the same. I'm opening the socket, and once I'm opening the socket, I'm going to close automatically when my try is ending, because of try with resources. This is the name of this try with round parentheses. Let's move forward. And what is the server statement? Almost always. My server should run always, unless I'm killing that process. So I have an infinite loop, a while true statement, which is running all the time. And is running all the time is doing what? The server. So the server have to receive the packet, to interpret it, to say, wow, okay, hello, I'm going to reply to you. And is replying what after is receiving the packet? Is replying with okay, always with okay, right? And when I'm replying, please pay attention. So on the receive, what I need to just to get the payload. But when I'm replying, I have to reply to the same address, which in the beginning, in the request, was the source address. And how I'm getting this, as you can see from the packet that I have received at line 24, in line 35, in this statement in here, I'm getting from the envelope the address, actually is the IP address. And from the same packet, from the same envelope, from the same letter, from the Indian philosopher, me as a Chinese philosopher, as a server, I'm replying by getting the port, because otherwise I don't know from which apartment from India came the request. And then once I have the address and the port, I can create yet another letter with another response. Look, buffer response is different than buffer receive. So in buffer receive, I have received hello. And here my buffer response, as you can see, is okay, is a string okay, and then I'm getting the bytes. And then I'm sending back to the network, right, to the Indian philosopher, me being the Chinese philosopher, I'm receiving the reply. So the Indian philosopher asks to me, what is life? I have answer to him is something beautiful, blah, 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 whatever is in philosophy. Here in our concrete practical example, I have received hello, and I'm replying with okay, right? So this is my program, and I have here breakpoints. I have breakpoints in line 20, breakpoints in line 24, line 27, 29, and 37 to show you step by step what is happening. And actually, I have implemented this diagram from here, right? I have my UDP server with a socket primitive, and the bind, as you can see in here, when happened the bind, when I put as a parameter in my datagram socket, I put as a parameter of the constructor the port number. This is doing the bind, right? On the Linux side, I did not insert the bind. Let me show you on the Linux side. I did not insert the bind because it's not mandatory, but I can insert it, right? But for the server side, is mandatory. This being said, let me prepare to run everything. And for this, I would start Wireshark, as I have told you. So I must start Wireshark. Okay, so once I have started Wireshark in here, I'm going to say what? Look, I want to capture Wi-Fi traffic. This is one thing. And I want to follow as a filter the UDP port, as I have stated, 8777, right? This is the one that I want to go through it. So look again into here, right? I'm doing the bind on this port. So I want to monitor, to supervise, right? To see exactly in Wireshark what is happening on this UDP port, right? Because the port is on 16 bits, 2 bytes, on the unsigned integer side of 2 bytes, I can state the value between 0 and 65,535, right? 65535, right? So this is the max number of my UDP or TCP port. Now Wireshark is listening on macOS, is capturing in promiscuous or non-promiscuous mode whatever packet is transceiving over the network. So this is very useful for the debugging. On the Linux side, as you can see in here, on the Ubuntu, I have my client. And on the macOS side, here in Eclipse, I have my server. And I want to put my server in debug mode. So what I'm going to do in here, I'm going to say, look, left click, right click, and I want to debug as Java application this. And what you see in here, so it's going to be debugged. Switch. You see, so here I have buffer response, buffer received, right? So these are both of them null. Okay, move forward. So I'm playing this with continue. I do not resume. I don't want to have step over, step over, step over. So I have resume fast. And I'm stopping, as you can see, I had while true, and then I'm stopping in here, receive. While I'm going to play resume, as you can see, I want to display on the screen with system out print line to display what I'm receiving, right? But my receive, I'm on the server side, is going to be a blocking call of this non-static method. So even I'm going to push resume, I'm not going to be stopped in line 27 unless a packet, UDP packet, is coming from the network. So you see, my process is running. I have my Java process running. And as you can see in here, my is binding on port 18777. So let me open the terminal for you to understand better. So shell, new tab, basic student. So net start, this can be done on Windows as well. -N, -A. Pipe communication between these two programs written in C, net start and grep. In Windows, you have find string, find str. So grep and port 8077. So as you can see, this is bind. If I'm going to stop this Java process that is running in Eclipse, let me show you, ps-ax, grep again, I want to see all Java processes in here. You see, I have my process with process ID, PID, PID, 90088, sorry, 90088. And you see, this is my process for my UDP server. If I'm going to kill this, of course, my program is going to stop. Let me kill for fun. Kill, send sigterm -9 to this process, 90088, right? This one from here. And what you are going to see, first of all, my program is going to stop. This is killed, right? So I do not have debug anymore on it. Second of all, my binding port is not working anymore. So here I do not have any other Java process. And here, let's start like this, voila. Then let's move forward. I config again, and my IP address, let me show you. So grep with 192, this is my IP address, 104. And let's find out very fast the Linux address because I want to check it out here. So I need a terminal anyway. On the Linux, which is going to play the role of the client, right? So on the Linux side, I have something like terminal, and here change profile to stud2 is not so big, the screen. Power working directory, I'm in here. I have config my IP address, as you can see, besides the Docker and whatever I have it, is not yet available because look, I have to enable the networking. Good. And now I'm going to ifconfig second time in the Linux. And what you see in here, my IP address is 192.168.0.108. So therefore, if I'm ping 192, this is 168, this is 0, this is 104, is pinging my macOS, right? And is replying, as you can see in here, Control C. If I'm going here and I'm pinging the 192.168 because I do not have firewalls. I shut it down, all the firewalls on macOS on Linux. I'm pinging to 108. This is the Linux. You see again, 104 is the Linux. 104, sorry, is macOS. 108 is the Linux. When I'm pinging, is replying. So each machines, macOS and this Linux, are seeing each other. The only thing I have to do right now, having Wireshark started, right, in here and listening, I mean monitoring, only thing I have to do is to restart in debug mode the server. Let me go in there very fast. Okay, so I'm going to debug this like this, UDP server, right? So I debug this. Once I'm going through this datagram socket, I would have bind again. Right now, I do not have clear. I do not have bind, look. So let's start, I do not have any bind. Right now, when I'm going to run here, I have the bind, meanwhile, because of that socket open. Look, I have bind on the port on macOS on the server side. And now when I'm going to continue the debug session, this receive is a blocking call. So I have to wait. Of course, I can do it asynchronous without blocking, but right now let's keep it simple. So blocked until my packet is coming from the client, from the Indian philosopher. The Indian philosopher is the Linux. Therefore, in Linux, very fast, I'm going to run the client. And as you may get used, I have cmd compile txt. And in here, I'm going to have something like this. Export environment variables, Control C. I'm going into the terminal. This one, I don't want to play it with debug in Linux as well. Here, I'm in the lecture number 10, is again, on the Linux, I'm the client, UDP. And on the client UDP, yes, I can do the compilation into this, and a compilation of both, but actually I need only the client. Right. So look, what you see in here, let me run right now. I both compiled them. I want to run. And as you can see, once I'm running my client, I have to pass as a parameter also the IP address and the port. So look at the first parameter. Let me show you. Okay, so clear, because I wanted to have it simple. So I have to go with this program with arguments of 0 to the macOS, which is 192.168, in my case, today, in this Wi-Fi network, .104. And on which port? 8777. I'm going to send hello message. Look, bam, I'm sending, and I have received, and I'm getting out of my blocking receive only right now when Wireshark captured this packet in here, and I'm going to discuss. So I received, as you can see, from the MAC address 08002759 to MAC address 1856, blah, blah, blah. Who is 1856? Sorry, 1856 is my MAC address. Let me show you. So look, if config, I'm going to put something like grep 18 2 points is my MAC address, right? 1856, blah, blah, blah. And if I'm going to get the IP as well, 192.168, right? So this is my IP address of macOS. So I have received from the Linux 108 to 104, as you can see. So on the frame level, I had MAC source address with MAC destination address. 1865, blah, 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 is the MAC address of my macOS. Then I have the IP, right? As I have told you, the encapsulation. I have 192.168.0.108 is the Linux, and is going with the envelope to my 192.168.0.104. And then I have the port. As you can see, if I'm going to expand this, I can have all the details, including the source, look on 4 bytes, C0A8006C, right? 6C, if you are doing in hex, you are having 6 multiplied with 16 at power of 1 is going to give you 96. And with C, which is 13, is going to give you the source address, which is 108, right? So add 96 with 13, and you are going to get 108. This is the source, and the destination, of course, is the next one, right? You have the destination here, right? And you see how it is getting. So we have seen actually the encapsulation, the MAC address, the MAC, the IP protocol, and then finally my user datagram protocol, which most important is having 2 bytes for the source and 2 bytes for the destination. And finally, after this, I have my data. Please be aware, I have hello and then a lot of zeros. Why? Because on the Linux side, as you can see in the source code right here, let me show you. As you can see in the source code in here, on the client side, let me show you. I have a hello only 5 bytes, as you can see, from 0 to 4. But please pay attention. I have my buffer allocated of 256 bytes. Because of this, in the network traveled all 256 bytes. Actually, because of what I have sent it, I have put the buffer entire length in line number 22, 256 bytes, and this travel in the network. And now coming back into our debug session, my server is doing what? Should do some processing. I'm doing no processing. Please understand yourself this. This is your homework, more or less. And I'm continuing immediately to provide the response. So continue in here. And once I have this, these buffers are equals in the same in the terms of address. And now I'm replying with the answer, right? So when I'm replying with the answer, the Wireshark is going to receive vice versa from the macOS from 104 in the suffix of the IP address to 108 in the suffix of IP address to Linux. Of course, vice versa from apartment 8777 to 466,491. And then let me show you. So continue. I'm going back in while true, back in receiving yet another packet from the network. So in the Wireshark, I have replied with vice versa. And as you can see in here, I replied only with 2 bytes payload, which is okay. Why? Why I did this? Because in my programming, as you can see here in replying, I'm getting the bytes only for these 2 letters. Okay. I did not use another yet buffer of 256. This being said, I finalized my lecture. I'm going to go together with you in online immediately because we have to put the presence in there. That's it. Questions? Do you have questions?